Okay, great. İyi akşamlar. Normally I would say good night, but it's a little late for you. So I will try and finish quickly so you can get to dinner. So anyway, I'm Wesley Chun. I am a developer advocate at Google, and I'm going to spend the next half hour with you talking about serverless computing with Google Cloud. Of course, I'll take questions afterwards, and if the conference is over and you have extra questions, there is a link and a barcode to an open Google Doc. Just go into the document and find the correct location for the DevFest here in Turkey, and just fill out your question, and the next time I check the document, I'm happy to answer your question. All right, so let's see if we can move ahead. So my background, or my mission, is to enable all current and future developers everywhere to be successful using Google Cloud and other Google developer tools and APIs. Before I came to the Cloud Platform team, I was on the G Suite team, so I've made a bunch of videos. So if you see any of my videos online, they're mostly related to G Suite developers. So that's Gmail, Google Drive, Calendar, Doc Sheets, and Slides. So I show developers how to code those. I'm not going to show you how to use them, but if you want to add reference to them in your application and use them from your app, then yeah, that's what my content is. And I've written on blogs many times, and I'm on Twitter quite a bit. My background is I've been a software engineer for several decades. I was one of the original engineers that built Yahoo Mail many years ago, if you've ever heard of that one. Mostly I do Python. I've written a few books. I've been a teacher in the same parallel career as an engineer. I'm a member of the Python community, and my academic background is there. Okay, so this talk is going to be 5 parts. We'll start with an overview of cloud computing so that everybody's talking on the same page, because everybody thinks cloud computing is something different than somebody else. So I want everybody to think the same way. And then I'll introduce you to Google Cloud so you know what Google Cloud is made of. And most of the time we will spend on the serverless platforms. That's the purpose of this talk. And then the second to the last section is showing you some inspirational ideas of some applications, variety of applications that you can build using serverless technologies and other Google Cloud tools. And then we'll wrap up by giving you lots of different links that you can continue your investigation. Okay, so cloud computing review. This is everything you need to know about the cloud. So what is cloud computing? Well, I'm sure many of you know that cloud computing is where you're outsourcing some sort of computing resource, whether it's actual compute power or data storage or even applications. And of course, one of the most well-known ones is email. Many years ago, in order to send and receive email, we would have to have an email server running on our machines, the same desktops that we use at work every day. And if you weren't able to do that, you could not send and receive email. And then as the internet became, bigger and bigger, and into everyone's homes, it was not reasonable for your grandmother to maintain SMTP on port 25, right? So, so that's how we decided, it's not a good idea for everybody to do this just to get email. So we need to have an email service that we outsource to somebody else. Let a professional manage my email service for me. So that's why we have, Gmail and outsourcing to Google, and Yahoo Mail outsourcing to Yahoo, and then Hotmail outsourcing to Microsoft, right? So you're choosing a vendor to manage the email for you because you just don't have time to do that anymore. So that's really the basis of cloud computing. And in the industry, when we talk about cloud computing, we break everything down into these 3 major service levels or pillars. So the first one that I'm talking about, speaking of email, email services belong to something called software as a service, or SaaS. So you see all the email services there, but it also includes things like, Google Workspace, which used to be called G Suite, which used to be called Google Apps, Office 365, and NetSuite. So these are basically applications that you've outsourced. Basically, anytime you get a web browser and you have to log into it, that's pretty much a SaaS application. So that's one type of outsourcing. Another type of outsourcing I described earlier is down at the bottom, which infrastructure as a service. This is where you're outsourcing the hardware. When you outsource the hardware, the reason is because you don't want to maintain it. You don't want to worry about upgrades. You don't want to worry about computers getting out of date and things like that. So you're choosing to rent or lease or hire compute power as well as big disk. So of course we have it in Google Cloud, and AWS has it, and Microsoft has it as well. But there's one catch, and the catch is if your purpose of renting hardware and big disk is to run an application, it may not be the correct tool. It may be the wrong tool. And the reason is because when you get the bare bones machine like this, when you get a VM, you're responsible for everything above it. You have to first decide on the operating system, is it Windows Server? Is it Linux? And then if Linux, then which distribution? And then which version of the kernel? So there's a lot of those decisions that have to be made. Then you have to decide on a database server, a web server, load balancer, and all of these other middleware pieces that your app needs before your application code, right? You can't even think about your application code until all this other stuff is taken care of. And so that's one of the reasons why this other third pillar, platform as a service, may be the right thing for you. Because if your purpose is to get some code online, these systems allow you to do that without thinking about the infrastructure. Okay, so we're just, this covers a lot of the serverless compute that is going to be in the rest of the talk. So that's why I'm kind of discussing it now. All right, so you write the code, you upload it to these systems, whether it be, us at Google or Heroku or AWS, with a service like Lambda and things like that. That's the power of platform as a service, because it allows you to just focus on, the code that you're writing and trying to run in your applications, and not as much about the infrastructure and all the other things that you have to, the layers in between your application and the raw hardware. Okay. So those are the three main service levels. And of course, like any large ecosystem, there's always going to be gray areas in between. So in between infrastructure and platform, you have services which are more than the raw hardware. Generally, these are networking services. These are data services. So, databases, data processing, data analytics. You'll find containers here. You'll find networking tools here. Okay, so all that is there. I mean, it is more than hardware, but you can't exactly upload applications to these systems and run them, right? They just don't handle application code. So that's why they're kind of in between. And then similarly, up here, you have systems which are PaaS systems, but they are what I call restricted PaaS systems, because they operate dependently, they are depending on data that live at the SaaS layer. So for example, Google Apps Script as well as Force.com are great PaaS systems, but generally if you're using Google Apps Script, you really need to have some kind of Google Workspace data up here, like Gmail messages or files in Drive or data in Google Sheets. And then similarly for Force.com, you really should have some Salesforce data to manage your customers and things like that. Because if you don't have any of those, there's no real reason you should use these restricted PaaS systems. You might as well use something more general down here, a regular PaaS system. And then the other thing I want to mention is that, with SaaS software, like Gmail, for example, if you find a bug, you can't fix it because it's not your code. The only thing you can do is file a bug or a ticket with the software vendor, the cloud vendor, like us for Gmail, right? And hope that our engineers fix it, okay? Similarly, if you're using a PaaS system, realize that you are creating a SaaS app for your customers, because if they find a bug, they can't fix the code either because it's your code. So they'd have to file a ticket with you or your company, right? So that's what PaaS systems are used for. They're used to make SaaS apps for your customers. All right, so I hope all that makes sense. Now, to look at it from a different angle, let's take it from the perspective of what are you responsible for? So if you're creating a SaaS, if you have a SaaS app, well, you're not really responsible for anything except for, if you're using, email, right? You're responsible for your own personal email settings, like your signature and things like that. But you've outsourced everything, right? The entire app is outsourced to a cloud vendor. So they're managing it and it's their responsibility. When you use a PaaS system, this is your application code and the data that belongs to that application, but everything else is outsourced. At the infrastructure level, you rented the hardware, okay, but you're responsible for everything from the operating system level on up. Okay, I kind of described this earlier. And lastly, if you're not using the cloud, you're on premise while you're responsible for everything. Okay, so hopefully this is a good sort of like high-level overview so that everybody's like talking about cloud computing in the same way. Because now we can take this, vendor agnostic view and kind of like focus on Google Cloud. Okay. All right, so what is Google Cloud? Google Cloud is an umbrella organization that produces two well-known platforms. Google Cloud Platform, which is what we're focused on today, as well as Google Workspace, which again used to be G Suite, which used to be Google Apps. A lot of people think, oh, the left side is all for developers and the right side is all for users. Not quite true, because as I mentioned earlier, I used to help developers learn about Workspace APIs. So behind Gmail, Google Drive, Calendar, DocSheet, Slides, there's APIs behind them, so you can code them too. So I have a little bit of an example of that later, even though this is not the main focus of this talk, but I'll show you some of that in a little bit, just to give you an idea that it can happen. Okay, so where does Workspace and Cloud Platform fit into our cloud diagram that we looked at earlier? Well, it's pretty easy. Anything that is SaaS flavored is going to be Workspace, G Suite, Google Apps flavored, because those are all, application layer things, right? And then anything else from the PaaS layer on down is GCP. So it's pretty easy to kind of like figure out the difference here. The line is very clear. Okay, so there's lots of different places that you can run code using GCP. We are only going to focus on the managed serverless products. All right, so obviously you can get VMs on Compute Engine. You can manage, a cluster, Kubernetes pods using, fully managed Kubernetes. You can, of course, run Kubernetes on your own on-prem systems as well. And then Cloud Run on Anthos is sort of our solution. Well, I'll describe Cloud Run, but Anthos is a tool that allows you to have hybrid cloud and multi-cloud. And then we also have App Engine Flexible. So I'm not going to spend too much time on those. If you really want to see this chart in full glory, where you can actually read everything, it's pretty difficult to read with a small graph like this. Just go to the link down at the bottom. And by the way, I'm going to provide the slides for everyone, so you don't need to, screenshot everything or spend too many horsepower in your head thinking about these things. Okay, so running your code on Google Cloud Serverless. So we do have VMs and we do have big disk, all right? So I will just have to say that most cloud vendors will provide you some sort of VMs. We provide all kinds of VMs from very small microsystems all the way up to really large VM that has 416 vCPUs, almost 12 terabytes of RAM, and 256 terabytes of disk storage. And of course, there's also Google Cloud Storage, which is like your massive data lake, right? That's where all your data goes into, because all of your data rivers flow into your data lake. All right, so it's your big giant blob storage that you can ingest all of your data into, and then you can just from there send that data to any of the GCP services if you want to process that data. So we do have VMs and big disks, but why would you want to use these? Okay, so as I mentioned earlier, if your purpose is running applications, you still have to do all that extra work before you can put your application code on it. Again, the operating system, database server, network, a load balancer, web server, all of those different things you're responsible for. It's a lot of work. It's already great that you can outsource the hardware, but why don't you outsource all the other hard stuff as well too? Okay, so I mean, you can use these, right? We support most versions of Linux as well as Windows Server that you can see there. And that's fine. If you want the ultimate flexibility, then yeah, maybe you should be using this. But for most of us who are application developers like myself, I'm really mostly focused on the code. So let's kind of like take a look at that angle. All right, so what is serverless? Obviously, it is a lie. Okay, of course there are servers. The main idea is that you don't have to worry about it. It is not your problem, and you only focus on your, the solutions that you're building for you, your company, your customers, and things like that. And then why serverless? Well, it's one of the fastest growing segments in cloud. At one point, I think it was the fastest growing segment in cloud. And one analyst, basically did some research and realized that, the corporate spend, which is how much money companies spend globally on serverless, has been growing the last couple of years. So these are in US dollars. So you have to kind of like translate from Lirashi to USD. But anyway, it's expected to double from 2018 to next year, and then double again a few years after that. So it's doubling every couple of years. The other cool thing about serverless is that it can handle the edge cases. Many times in technology, we say, do the 80-20. Make your application work for 80% of the cases and don't worry about all of the 20% corner cases or edge cases. But what's great about some of our serverless tools, or some serverless tools, not all Google serverless tools do auto scaling, but most of them do. And I think the same goes for other cloud vendors as well. So if you do go viral, and let's say you have a small company and you spent most of it hiring engineers and you really didn't buy enough hardware. Well, if you go viral, what happens is your servers won't be able to handle the load from all your new users. And so they're going to be upset and not use your service. And then also your existing users used to be happy, but now they can't access their service either, so they're not happy. And so everyone stops using your app, and then you're going to go out of business. Not good, right? Similarly, on the other hand, what if you spent too much money on hardware and not enough on engineers to actually build your application? Well, you've just wasted all that money. You don't have a solution. You don't have enough users, and you're going to also go out of business. So the other cool thing about serverless is that if your code's not running, you're not paying, because you're not, your code is not on any instance. There's no instances up, which means you're not getting billed, which means there's really nothing to pay. So that's the other cool thing about serverless, is that it handles a situation where if you're just not getting the traffic, then it's not an issue. But if you had VMs, well, guess what? You're paying for the VMs whether they're live or not, whether they're serving traffic or not. As long as they're up, as long as you're renting big disks, you have to pay for that, and that's not the case with serverless, right? Your app has to be running. Of course, there's a cost for storage, right? You just, if you have like multi-terabytes of data sitting there, you still have to pay for that, right? Okay, cool. So when we talk about serverless, lots of different things are serverless, all right? But we want to focus on serverless compute, which is the, kind of like the one in the middle, like you see over here. When we have, we can have databases, you can have a cloud SQL that's either a MySQL or a Postgres or a SQL server in the cloud. And of course, you're not managing the servers. So that, that is also serverless, right? But when we're talking about serverless today, mostly we're talking about serverless compute. So that would be in these two categories here. So very much platform as a service flavor. So that's sort of like the middle one. But yes, it's also true. There's lots of other serverless products too, but we're not focused on them as much. Okay. All right, let's talk about App Engine, which is app hosting in the cloud. So App Engine exists because, developers spend too much time thinking about those other things that they have to put on their infrastructure, right? Remember, operating system, database server, web server, all those different things. It really delays the speed at which you can execute and get a service available around the world quickly. So App Engine was created to specifically solve this problem. You write the code, we handle this stuff for you, we help you scale, we deploy your app so it's available globally. We're going to use familiar programming languages that you're familiar with. We have a local dev server so you can do testing before you deploy and things like that. So you take all these little brown boxes and put them into one giant box called App Engine, make it available in multiple languages that people are familiar with, like Java, Python, Node, JS, Ruby, PHP, and Go, and then let them do their work. So here's your, this is the hello world. So the smallest Python web app you can write using the Flask web framework. So there's one configuration file. You have your main Python file, which is just hello world whenever you go to / for your application website, and then whatever, packages that you have. So in this case, it's Python, so requirements.txt. So if it was Node, it would be package.json. All right, and I just want this web framework called Flask. I want higher than version 102. And then once you have all this in a folder, then you just do gcloud app deploy. You answer all the questions, and then in less than 60 seconds, in usually about a minute, under a minute, your app will be available globally around the world, and you get a free domain name as well too. Obviously, if you have a company, you can just create a DNS to point to this app. So if you want to build this yourself, there's a link to the quick start down there. Popular use cases for App Engine. If you don't have a web app, you can actually write a mobile backend. So that's actually a very popular use case for App Engine. It doesn't even have a user interface. You know, the mobile app just making HTTP post calls and get calls to your App Engine app, that's perfectly reasonable as well. A lot of gaming, social apps on it, consumer apps, school apps, because App Engine has a pretty generous free tier. So we'll mention the free tier towards the end of the presentation. And of course, enterprise apps as well too. Okay, if you want to get started, here's another link to the quick start. And you know, once you get the slides, you can just click on it because the PDF has the hyperlinks connected. So there's a quick start to get you started. You can also get the quick start in Java, Node, PHP, Go, and Ruby as well. Okay, let's talk about Cloud Functions, which is function hosting in the cloud. All right, Cloud Functions is where maybe you don't have an entire app. You don't want to think about a LAMP stack or a mean stack or any kind of like web stack, right? You just want to deploy small little pieces of code, functions, microservices, and things like that. And it has some features that App Engine does not have, and those are going to be in bold font. Okay, so like App Engine, like Cloud Functions like App Engine, you can make an HTTP call to it. That's pretty easy. Something that Cloud Functions can do in addition to that is it can process background events like I sent a message in through PubSub, which is our message queue system, kind of like Apache Kafka. If you've never used PubSub before, they're kind of similar. Or maybe you uploaded a new file to cloud storage, or maybe you logged into Firebase or something. So you can actually trigger Cloud Functions based on any of these events. And like App Engine, it's also highly scalable, highly available, and you only pay if your code is running. You code on the command line, just like App Engine, or something that Cloud Functions can do uniquely is you can also do everything in the browser. You can create your Cloud Function in the browser. You can code the Cloud Function in the browser. You can deploy, and you can test. You can do all of that in the browser, so you don't even have to worry about having a local development environment. There's also a special version of Cloud Functions specifically for Firebase, because Firebase is our mobile development platform, and maybe you just want to have, Cloud Functions handling all the little things from your mobile app. You can use the Cloud Functions version for Firebase. They're the same product, but it's outfitted more for mobile apps, whereas Google Cloud Functions is more for cloud-based applications. So either product, they both work very similarly. Depends on your use case. And it's available for all these popular languages. Not as many as App Engine, only because Cloud Functions is newer, but we're introducing new languages all the time. So keep an eye out. I think there are some new languages that are in beta already. Okay, here's your hello world. In Cloud Functions is a one-line hello world. In Python, the deploy line is a little bit longer than App Engine's because you don't have a config file anymore. So you have to put all these different things on the command line itself. And then like App Engine, in less than 60 seconds generally, your app is available globally, so you can curl to it, or you can use a web browser to hit it up. So if you want to try this quick start, there's the link to it, but I also have a thing too. But here's just one quick peek into what it kind of looks like in the browser. Our user interface changes quite often, so it doesn't exactly look like this anymore, but it's going to be very, very similar. So the general tab is controlling all the different aspects of your Cloud Function. The trigger is how you want your Cloud Function to be called, whether it's HTTP or some cloud storage or Firebase activity. You can edit your source code, and then here's the tab for testing. So I'm not sending any payload to my Cloud Function. I click test the function, and they get hello world. Okay, so you can do everything in the browser. And so here's a link to the Cloud Functions getting started that you saw earlier. All right, so the second to the last one is Google Cloud Run, which is container hosting in the cloud. So, containers have gotten very popular recently, right? Because it lets you bundle anything. You can use any language, any library, any binary. There's a whole bunch of different certified, secure base images that you can use. It's, having a Docker container is an industry standard, so it's very, very flexible. On the other hand, there's also serverless, all right? Serverless is great. I just told you about App Engine and Cloud Functions, but maybe it doesn't support all the different language. Maybe I want a different language. Maybe I have a library in C++. Well, I didn't see C++ in those languages that you listed. That's true. How can you use binaries? Because most PaaS systems are restricted where you cannot have binaries because it's not exactly secure, right? Or maybe you're afraid of being locked in. Maybe you have to use a cloud vendor's specific APIs, and now you can't move it somewhere. Okay, the problem is why do I have to choose between the flexibility of containers and the convenience of serverless? Why can't I get the best of both worlds? And you couldn't until Cloud Run. So with Cloud Run, you're deploying containers in a serverless way, which means you can use any language, any library, any binary. Okay, so that part is great. The only thing we ask of you is that you leave an HTTP port open to us so that we can call into your service, and that it is stateless, so that anytime you call your app, if multiple calls come in, it doesn't have any side effects into your database, it can't corrupt it and things like that. So those are sort of like the two main requirements. So you take your application, you bundle it into a container using Docker or Cloud Build. Your container goes into a container registry, and then once it's in the registry, then you can deploy to Cloud Run. We also have a thing where, one of the features of Cloud Run is that you can do push to deploy from Git, or what we call Git ops. So as soon as you do a Git push, it will trigger a whole process where it will build your container from that code. It will pull down that code, build a container, and then deploy it to Cloud Run all in one shot. And then just like App Engine Cloud Functions, you also get a free domain name with your app as well too. Okay. So that's Cloud Run. Here is your Hello World, which is very similar to the App Engine one. Okay, the only difference is that I now have some main code running that starts up a web server on port 8080. All right, but everything else is pretty much the same. Here's your quick start here. And of course, we, like I said, any language, any library, any binary. And so this is the starting list, right? This is not the complete list, but this is a list. And you can read up on how to, launch a container using those languages on Cloud Run. All right, with Cloud Run, of course, it's in a container, and typically you would have a Docker file for containers. You probably should have a Docker ignore so that you don't bundle everything into your container image. All right, and then you have requirements.txt file, just like App Engine. So you can use gcloud build submit to create your container and push it into the registry. So that's like Docker build and Docker push. And then you can go and deploy that to Cloud Run. So this is like Docker run. And then, of course, like I said earlier, you have a URL too. Okay, there is an alternative if you don't want to have to maintain your Docker files. All right, because Docker files can be very tricky. You can have additional layers that make your container not optimal. So there's a new thing called build packs. Well, it's not really new. They've been around for a long time. Heroku kind of started them, about 9 years ago, and they've now become an industry standard. So it's basically a way to build a container without a Docker file. What happens is the build pack will go and investigate what application you have, what languages you're using, what tools you're using, and it figures everything out and builds the container based on what it can see in your source bundle. All right, so it's more convenient. So take a look at the blog post. It just came out a couple of weeks ago. So build packs are very new, and it's an alternative for Cloud Run, or just for you to build a container without using Docker. All right, and so here's your quick start for Cloud Run. All right, so the last serverless product, we jump from GCP over to the G Suite side. So this is Google Apps Script. What is Apps Script? It is a customized serverless JavaScript runtime for automation. And so automation is the main thing, but it can also be used to extend and integrate with Google Workspace, which again used to be G Suite and Google Apps, as well as other Google and external services. So what does it look like? So here's your hello world in Apps Script. So this is a one-line JavaScript application that connects to Google Sheets. So instead of using APIs, it uses objects. So I'll just do spreadsheet app.getActiveSheet.get cell A1, and I want to set that string value into cell A1. I save it, I go through the OAuth prompts like usual, and then boom, I have hello world in cell A1. And while this is very boring if you did it yourself, because most people have used spreadsheets before, and this is a very boring app, but it's much more exciting because you wrote code to make this happen. All right, so I have a video on this one if you want to find out more, but it's just a beginning of kind of like some excitement. But this is not a real useful application, right? So how about something more useful like actual data? So here is a spreadsheet, a Google Sheet that has the address of Google's New York office. All right, if you want to visit. Let's do something with this. So now notice the data is in cell A2. So we're going to blow this application up from 1 line to 4 lines. but let's make it do something useful. So I'm going to connect to the spreadsheet again. This time I'm going to get cell A2, but instead of sending the value, I'm going to get the value, which means I'm going to read the address out. Then I could say something like, hey, Google Maps, can you make me a new map and put a pin or a marker on this address? And then line 4 is, hey, Gmail, can you email my friend, send them this map as an attachment so they can come join me for lunch at the Google New York office? All right, so 4-line application that touches 3 different Google products. Well, theoretically 4 if you count AppScript. All right, so AppScript, Sheets, Google Maps, and Gmail. And this app is much more useful than the Hello World one, right? And it's only 4 lines of JavaScript. So imagine how much power you have at your fingertips. And by the way, it's not limited to Google technologies only. I can use the JDBC object to connect to an outside database. I can use URL fetch and talk to any service that I can reach from Google. You know, any public service I can reach from Google. Okay, so you're not just tied into to Google technologies and Google products. And there's a video for that one as well. And if you want to code this line by line, I created a code lab, which is a self-paced hands-on tutorial, so that you can write your own version of this this app. Okay, so what you can do with that, you can expand that into an application where maybe you're visiting 4 of your biggest customers in New York, or maybe you have a book club or a user group meeting, like a GDG. You can use the Gmail API to send out reminders of monthly meetings. You can use the Gmail Calendar API, the Google Calendar API to put the events in their calendars. Google Maps, as you know, also has walking and public transit, biking, driving directions. So you can actually give, you can use AppScript to pull that out of Google Maps as well. So there's a lot of different things that you can do with this technology. Okay, so that is it as far as all the technology and serverless tools that we have go. Let's wrap up by showing you a couple of inspirational apps, and then I'll give you some links to follow up. So my colleague wrote this great app that he was able to add custom intelligence to Gmail by analyzing Google Workspace data using GCP. So what did he do? So his use case is, we get a lot of email. Everybody does. Gmail does a great job of filtering the spam messages, but even within the legitimate email, maybe there's only a few messages that he cares about. And in his case, they're messages with attachments that have pictures of birds in them. Okay, I know that sounds really funny, okay, but kind of bear with me here. So what did he do? He wrote an app that every time he got a message in his Gmail inbox, it would send that notification to Cloud PubSub, which is our message queue service. This is the service that's like Apache Kafka, if you've used that before. PubSub will then take that and trigger a Cloud function, because that's one of the things that you can trigger a Cloud function with, a PubSub message, which will take that email message, extract all the attachments out, send it to our Cloud Vision ML API. Cloud Vision API's goal is to analyze a picture and try and determine what is in the photo, and it returns back a bunch of labels. And so if it categorizes bird as one of the images that was found in that attachment, then the Cloud function will call the Gmail API to star that message, so that when my coworker logs into his Gmail the next time, without running any code himself, okay, you can see that some of his email messages already have stars next to them because he wrote this automation tool. So this kind of demonstrates the event triggering mechanism that Cloud Functions has. He didn't run that Cloud function. It happened automatically whenever a new message came into his inbox. Okay, so if you want to find out more about pushing Gmail messages to PubSub, here's a link for that. If you want to find out how PubSub can trigger a Cloud function, there's a link to that. If you want to read more about this app, take a look at his blog post that he wrote. I'm sorry that the URL is kind of long. I didn't create a short one for that. But if you just want to say, forget that, I just want to look at the code, it's on GitHub. All right, the last sample app is one that I wrote along with, sort of like we presented at the same time at Cloud Next a couple of years ago. But this one helps you go from big data analysis to slide presentation by accessing GCP tools from Workspace, which is sort of like the opposite of the previous app that I just showed you, where he reached into G Suite and Workspace tools from GCP. Now we're going the other way around. So big data is everywhere. It's everyone has to deal with it. It's a common thing to look at data now to get insights on your business and customers and things like that. And one of the great data analysis tools we have is called Google BigQuery. So it lets you analyze multiple terabytes of data with just simple SQL. And normally you can't do that with a relational database because your select will take too long. All right, but with BigQuery, you can just throw in multiple terabytes of data, you issue some SQL, and you'll get results back in seconds. It's really a great and fun tool. But what do you have here? When you're done, all your data is in a nice format on the web, but you can't really use it in your app. You could download it as CSV, but that's not really that visual, right? So you've done the hard work, but your data is not visual enough for people. You need to make it more, accessible to everybody, not just CSV file. It's not it's plain text, but it's not necessarily that user friendly to look at, right? So it's like these stairs. You've done most of the work, but it doesn't look that good. Let's do the last 20% and make your data look great. For example, let's put it into a spreadsheet because that's much more visual than a CSV file. And if you're going to be using the Sheets API, you might as well tell it to make a chart based on that data, right? And if you're going to do that, then you might as well, ingest that data into a slide presentation because you probably have to show your boss anyway. And then you might as well import that chart as well. And in fact, you can build an entire slide deck based on that data that you put into the spreadsheet. So this is an app script application. I, as the user, I'm going to call my application. What it's going to do is it's going to send a request out to BigQuery. It's going to get the results back. It's going to throw it into a sheet. I tell Google Sheets to make a chart. And then from there, I import both the data into Google Slides. I create a brand new slide presentation, import the data, and then import the chart. And then now I've gone from big data analysis all the way to executive-ready slide presentation. So I did the last 20%. I did hard work, which was getting the correct data, the correct query, and getting the data. But now I did the last 20% to make that data presentable to my management. And this is, by the way, all less than 150 lines of JavaScript. It's not exactly a huge application. All right. So you can build this this app yourself using the tutorial. I created a video on it as well. You can also go and look at the source code, and I presented this at Cloud Next a few years ago. Okay, so to wrap up, let's give you some links. So cost, a lot of people ask about cost. One of the trickiest things about serverless is predicting cost, because normally when you have a VM that's up, you can just count how many hours it's going to be up every month, and you can kind of like figure out the bill from there. But serverless is tricky because you're only billed if somebody's using it. So you'll pay more when you have more users using your app every month, but you'll pay less when you have fewer users using your app every month. So it's a little bit trickier. So some people want to know, like, what is the free part? So there's a free trial. So if you're a new user, you get $300 US of credit, which is good for 90 days. So I would not activate the free trial until you're really ready to use it, because the 90 days will disappear really quickly. So think about your app, design it, make sure you have the code, and then start the free trial. And that's good for any Google Cloud service that you use. It could be VMs, it could be disk, it could be Cloud SQL, it could be serverless, it could be AI, ML, it could be anything. There's also an always free tier. So what that is it's independent of the free trial and any kind of education grants. But what happens is there's a certain number of products in GCP that you get certain amount of usage free every day or every month. So for serverless, for App Engine, you get 28 hours free to operate every day. If you get a regular instance, you can get a larger machine and you get 9 free hours a day. You get 1 gig of storage and 1 gig of network outbound network traffic per day. And then Cloud Run and Cloud Functions, you can make 2 million calls a month for free. And then gigabyte seconds is basically you have 1 gig of memory running every second. How many of that can you have? And then how many vCPU seconds per month do you have? And then how much network egress do you have per month? So anyways, that gives you a brief idea as to what you can get for free. And then you just pay for usage on top of that. So you don't get billed until you consume all of the free tier. All right. So to wrap up, why go cloud? Cloud computing has taken the world by storm. You really should be using it. It's not too late to start. Really, you want to be the next generation workforce that is cloud aware, cloud ready. You know about cloud. You've used cloud before. You're comfortable with it. Why Google Cloud and why serverless? Of course, we have many different features like compute, storage. You want to outsource all this stuff as much as possible so you can focus on the solutions you're building for yourself and for your customers. So serverless lets you just focus on those solutions and not think about infrastructure. And there's lots of interesting possibilities if you use both sides of Google Cloud, GCP, as well as Workspace, G Suite, Google Apps, right? And like those inspirational apps I showed you. Okay, so other Google APIs you may want to consider. We discussed the G Suite workspace stuff. Firebase is our mobile development platform and real-time database, so that is what you should use if you're building a mobile app. If you want to build a beautiful dashboard, a visualization tool across all of your data, Data Studio is a nice free tool from the Google Analytics team that helps you do that. You can build voice-driven apps using Actions on Google to write apps for Google Assistant and Google Home, and it uses Dialogflow as well. YouTube has APIs, Google Maps has APIs, we kind of discussed that. And then Flutter is a development platform that lets you write native apps in Android and iOS and the web with just one source code. All right, so you just write your code. It's in Dart, so you have to learn a little bit of Dart, which is basically, think of it as like modern day JavaScript. But once you do that, you have one code base, and instantly you have a native app on Android, a native app on iOS, and a web version. So it really saves a lot of time if you have to do all three. And then some links to documentation for GCP, for G Suite, some links to the code labs, intro code labs for App Engine, Cloud Functions, Cloud Run, other code labs, other videos, other code samples. If you're familiar with AWS and Azure and want to compare them with GCP, there's links for you here, and then specific page just for serverless products. And that is it. So add me to your Twitter if you want. This is a link to the slides as well as the barcode that both go to the slides. And if you notice the progress bars down at the bottom, that is written in Google Apps Script. And remember how I said you could use it to extend Google tools. So Google Slides does not normally have progress bars, but you can write your own using Google Apps Script and create a Google Slides add-on. So there's a link to a video and blog post to show you how to do that. And again, this is the document with if you have extra questions after time is after the conference is over and you have extra questions. All right, teşekkürler.
Well, we thank you very much. I find the presentation very informative and inspirational too.
Great. Are there any questions?
Well, there is no question, but we have a comment.
Thank you, Barris.
Well, thank you very much for your time and interest.
Great. All righty. Take care, everyone. Again, drop me a note in the question document if you think of something later. I'm happy to help.
Thank you. Okay, have a nice day.
All right. İyi geceler.
İyi geceler.
Okay, good night.